morning, dear students. Today I am going to begin second part of the chapter electric current, that is electromotive force, terminal voltage and internal resistance of a cell, combination of resistor. But first we will discuss about the electromotive force and the terminal voltage. Electromotive force. Before moving to this topic, let us discuss some previous terms. In the previous classes, we have studied that, or in the previous classes in the lab, chemistry lab, we have seen that the cells are made up of two electrodes which are placed in the suitable electrolyte. In the labs, you have seen that the two rods are kept in a solution. That rods are called electrodes, and the solution in which it is kept is called electrolyte. This type of diagram, this type of figure you get where the two rods, one is positive and the other is negative terminal, and they are placed in the suitable electrolyte. So when the wire or some component, electric component is connected with it in the lab, then we can say that the electric current starts flowing from positive terminal to the negative terminal, because the electric current flows from positive terminal to negative terminal, but the electrons flows from negative terminal to positive, that is from excess to defect of electron. The electric cell maintains a constant difference in potential between the two conductors. The constant potential is maintained inside the electrolyte or inside the cell. The electrolyte, if in electrolyte we take suitable liquid. In electrolyte, for example, we have taken sulfuric acid, that is H2SO4. In water, dissociates into the positive ion and the negative ion. As we all know, H2SO4, we have H plus ion and SO4 minus ion. So when the electrodes are placed in the solution, then it dissociates, it separates these two ions. One behaves like positive and the other behaves like negative. The negative electron impart electron to the negative terminal, and positive ions, that is H plus, gains electron from the copper electrode. For example, two electrodes of copper are placed in it. Then one behaves like positive and the other behaves like negative. Which gains electron gets negative charge, and which loses electron gets positive charge. So electromotive force is the constant potential is maintained in the electrolyte. So electromotive force is the potential difference between the terminal in the open circuit. Open circuit means that I have not discussed that any component is connected in the cell. It means that in this condition no current is flowing in the circuit is open. In this condition, the internal potential means the potential between the two terminals when there is no current or when the circuit is open is called electromotive force. It is also called EMF, electromotive force. Its symbol is represented by the letter epsilon, and it is the potential difference between the terminals. So the unit of potential difference, that is volt. Next we have the terminal voltage. The next topic is terminal voltage. Terminal voltage is also a type of potential difference, but in this condition this circuit should be closed. When the circuit is closed, then the potential between the two terminals of the cell is called terminal voltage. Its symbol is V and the unit is volt. So we have some factors which affect the EMF of the cell. First is the material of the electrode, and the second is electrolyte, because in the case of electromotive force we have only the cell, and cell consists of electrodes and electrolyte. It means that electromotive force only depends on these two factors, that is electrode and electrolyte, its material. The strong acids, if strong acids are used as electrolyte, then they will give more current, and the weaker gives less current. So you all will revise these two topics. The next topic will be explained on the next turn.